All right, we're going to take a look at this series. Looking at it, it's not geometric, so we can't use that. It's not alternating. We can't use the alternating series test, although that would be great if we could, because that's an easy test to use. The test for divergence, the limit of these terms is 0, so the test for divergence doesn't help us out. It just tells us this may converge or may diverge. And for the limit comparison test, I'm not sure what to choose for a comparison, because that factorial in there is weird. This is actually a perfect place for the ratio test. So the ratio test, we define R for ratio. This is a limit as k goes to infinity of the a sub k plus 1 term in absolute value over the a sub k term. So it's a ratio of the successive terms that are being added together. So what is that? A sub k plus 1 is 3 to the k plus 1 over k plus 1 factorial. And a sub k is 3 to the k over k factorial. So that's our ratio. This is the limit as k approaches infinity of, it's a division of fractions. So we multiply by the reciprocal. And we do a lot of cancellation stuff. So now we're going to cancel things. Let's see, we have k 3's and we have k plus 1 3's. So almost all of those cancel. And we're left with just 1, 3 in the numerator there. So we have a 3 divided by, now the k factorial over the k plus 1 factorial, we just saw how that works, right? K plus 1 factorial is k plus 1 times k factorial. So the k factorials cancel. And we're left with just a, k plus 1 down there. So we have a k plus 1. Now, that's a limit that we can find. The limit as k goes to infinity of 3 over k plus 1 is 0. That ratio gets smaller and smaller as k gets bigger and bigger. That's 0. 0 is less than 1, and therefore this series converges by the ratio test.